AI development has matured into a heavy industry operation. This requires a new physical infrastructure, the AI factory. Unlike a traditional cloud data center built to host websites and databases, an AI factory is a facility engineered entirely to support autonomous and agentic systems. The catalyst accelerating this physical build-out is NVIDIA's decision to move its Vera Rubin AI platform into full global production. The timeline and exact scale of this transition were confirmed on May 31st at NVIDIA GTC Taipei. For years, technology companies focused on isolated AI model development. Now, the mandate is highly interconnected, enterprise-level AI operations. The hardware targets are massive. NVIDIA designed this architecture specifically to network facilities containing up to 1 million interconnected GPUs. Writing better algorithms will not determine the next phase of market dominance. That advantage belongs to organizations that can physically deploy and power hardware at an industrial scale. Standard generative AI relies on a predictable workload. A user submits a prompt, the system infers a response, and the computation follows a linear path. Agentic AI operates entirely differently. Because it performs continuous reasoning, the system autonomously queries, verifies, and endlessly loops data. This constant looping creates an exponential increase in input and output strain. Standard hardware simply exhausts its available bandwidth. Even NVIDIA's previous generation architecture, Grace Blackwell, reaches a severe bottleneck under these exact continuous reasoning workloads. Vera Rubin is the specialized architectural solution engineered to clear that bottleneck. This chart shows a side-by-side scale comparison of processing capacity. At scale, Vera Rubin delivers up to 10 times the agent processing throughput of Grace Blackwell. Enterprise software providers and financial institutions require this specific throughput increase to safely and reliably deploy autonomous agents. Software can no longer evolve in isolation. Hardware must be custom architected to accommodate systems that never stop reasoning. Wiring together 1 million processing units introduces a fatal systems engineering problem. Using standard networking protocols across that distance guarantees latency collapse. Traditional copper wire and standard Ethernet topologies physically break down when subjected to the sheer volume of continuous agentic data loops. Solving this requires replacing electrical signals entirely with co-packaged optical networking. NVIDIA addresses this directly with a new technology layer called Spectrum-X Ethernet Photonics. Instead of relying on external routers, Spectrum-X physically embeds optical networking directly into the AI data center's switching infrastructure. This allows operators to seamlessly scale computing clusters across vast physical distances within a single facility. Global cloud providers rely on this exact networking layer to assign complex, cross-organizational tasks to their AI agents. The network itself is now the computer. Without the photonics layer, a 1 million GPU factory collapses under its own internal communication delays. Executing this hardware transition requires an industrial footprint equal to the engineering. NVIDIA has transitioned the Vera Rubin platform into a fully operational manufacturing program. Production is currently scaling across more than 350 factories, operating simultaneously in 30 different countries. Taiwan acts as the critical anchor for this network, with over 150 specific ecosystem partners participating on the island alone. The speed of this deployment is forced by hyperscale data center operators injecting massive capital investments to secure the earliest shipments. Industrial manufacturers and sovereign governments are competing in this exact same capital race to acquire physical infrastructure. In the AI sector, executing supply chain logistics now dictates competitive advantage just as strictly as silicon design. In this new era, market advantage now depends on direct access to these massive, physically deployed cloud infrastructures. Because these factories centralize compute power so efficiently, they create a distinct entry point for the African technology ecosystem. Instead of funding the multitude to existing AI factories, capitalizing on this requires immediate investment in localized cloud capacity and digital infrastructure readiness. Robust connectivity acts as a pipeline, allowing local enterprises to utilize global AI factory throughput for complex automation without the need to build the underlying hardware. The Vera Rubin rollout indicates that the roles of AI competition have moved past the research phase. The race to industrialize intelligence has left the laboratory. The winners of the next decade will be those who can deploy and access physical computing architecture at a planetary scale.